Well, thank you, Gail. I really appreciate the introduction, and thank you all for joining today. This is a really fun webinar. This is actually our first webinar of the academic season as well, so I'm really glad you can join us here. And just to give you a little bit of context here of what we're going to cover and what we want to talk about, this webinar is really meant to be a first or second touch of JMP. Maybe you've seen our Getting Started webcast or one of the others, but really I'm going to take this webinar from the point of view that you really don't know too much about JMP and you want to see what it can do for, if you're a teacher, your class, and if you're a student, what you can do with it in your class. And so I'm going to take this from sort of a basic standpoint, but if you have seen JMP before, I hope I can point out some special tools or tips that maybe you haven't seen before. So hopefully you get a lot out of this. And before I jump in, I'll give you a little bit of my background, just so you have a context for where I'm coming to this from. My background, I'm not a statistician, in full disclosure. I'm actually an experimental psychologist, but I'm really an applied researcher. And I came to using JMP about 10 years ago, actually, in grad school. And I've been using it ever since for research and for my own teaching. I teach at the University of California, San Diego. And I find JMP to just be an amazing tool for the applied scientist and the applied researcher. There are plenty of statisticians who use our software who love JMP, but really JMP was made for the scientist or for the student and professor who really want to get the most from their data, but don't really need so much of the statistical theory to do it. And so with that background, let me step through a little bit of what we're going to cover, just to give you the broad overview. And then we're going to dig into some of the what is JMP ideas and the basics of JMP. All right, so just to give you the broad overview, we're going to talk a little bit about why JMP is a piece of software at all. And I think this gives a little bit of context. This story gives context to how JMP works. And that's really what we're talking about today. How does JMP work and how does JMP think about data? And the history of JMP illuminates that idea a bit. Then we're going to step into the JMP basics section. And in here, I'm going to really formally get into what I call the mind of JMP, how JMP thinks about data and how JMP needs you to interact with it. And then we're going to talk about how we actually get data into JMP and how we can create a new table. After that, I want to show you rather briefly several very big platforms. So I'll talk about platforms and what they mean in JMP. But these are very important parts of the software, and I want you to have at least some exposure to each of these so that you know where to go when you start learning about these topics in class or when you start teaching them to your students. So we're going to cover some essential platforms. Some of these are my favorites and really the most used in JMP. And then finally, we'll finish up with talk about resources. So there's a lot of content that we develop on the academic team specifically for learning JMP and for teaching JMP. And so I'll point out a couple of these, and Gail already illuminated to some of them. So the JMP academic community is certainly worth visiting. So community.jmp.com, and it should say /academic. And when you go there, what you'll get is the academic user community, which right now is set up into several rooms. So a room for teachers sharing content. We have a room where students discuss JMP and best practices. But the place I want to point you to now is this Academic Resources Center. Because if you go here, you can visit a number of different collections of resources. And I'm just going to point you to one right now because this will be important later if you ever want to watch this recording. Under this collection for academic webinars, I'll put the recording of this video today. So as I go through things in JMP, don't feel like you have to get every step right now since you can revisit this recording whenever you like. So visit this collection and you'll see many other webinars that we do on the academic team. Now, the other link I had on that page was actually the Learning Library, and this is where you get to if you go to jmp.com/learn. Now, we'll come back to this at the end, but the Learning Library is really a location where you can get PDFs and videos for how to do different topics in JMP. So, for instance, if you were interested in multivariate methods, you can click on that section, and we have a number of different guides and videos structured around multivariate methods. So you can watch a video on cluster analysis or principal components, or you can even get a one-page PDF that you can use to learn the method. Or if you would like to embed these in a class or a syllabus, they're all free use, and we create these just for you. So these are all freely available on the website. So we'll come back to that at the end. But for now, what I want to do is actually step into some of our real content, sort of to get an idea of what JMP is, and to show you JMP if you've never seen it before. And in fact, we've been in JMP this whole time. This is actually a little JMP window I'm using, a journal actually in JMP. Something we won't talk about too much today, but it's a nice little feature of JMP for making lectures or for giving content or webinars like this. So I'm going to expand a section, and let's actually step into why JMP is a piece of software at all. It's actually been around for about 25 years. This is the 25th anniversary year, in fact. And it was created by John Saul, who's one of the co-founders of SAS. And John was really interested in the visualization and the analysis of data in a way that was different than what we used to do back in the 50s and 60s. That was a time when we had servers and we had clients. And in the late 80s, the Macintosh computer and the mouse, these were all new technologies that were revolutionizing how people used their computers. And so what John Saul thought was, why don't we make statistics and statistical analysis more like using a graphical user interface, more like using a Macintosh computer, where we can click, where we can drag, where we can interact. And that's what JMP was. So JMP 1 was born in 1989 on the Macintosh computer, and it was meant to be a graphical tool to explore and understand data. So instead of being a tool for the statistician, this was a tool for the scientist and for the engineer. And JMP really makes data visual, it makes it interactive, and it's a powerful way to understand data. And if you've never seen a JMP analysis before, I just have some quick examples I want to show you, and then we're going to take a step back and we'll talk about why JMP is working the way it does and how we can use JMP really most effectively. But let's look at some JMP output. So I'm going to open up a sample data set, and I'll tell you how to get to these in just a minute. But these are some interesting data. These are actually from a famous statistician, Ronald Fisher, and he had collected data on different flowers, so different species of irises. And so we're just looking at the raw data here in the table. So this is actually a JMP table with all of our observations and measurements for different attributes of the flowers. Now, what I mean by JMP being visual and interactive is that when I produce output in JMP, it's not static, it's actually touchable. We can interact with it. So I'm going to go to a platform, and I'll talk about these a lot more in detail in a second. So I'm just going to produce some output rather quickly by telling JMP I want to look at the distributions of all of my variables. And what JMP produces rather quickly is an interactive output window. And what I mean by interactive is, let me click on the Virginicas, and we can instantly see where those flowers are in every other distribution. The Virginicas tend to be the longest or widest petal width and length, but mid-range in sepal width. So the interactivity of JMP, being able to click and drag, these are features that they're not just toys. They allow you to really illuminate the meaning in data. So JMP is visual, it's interactive. It's unlike most statistical software you've ever seen. You can visualize in 3D and drag plots around. It works like a modern piece of statistical software because it is statistical software designed in the modern age. And so JMP is meant to be this visual interface, this way to touch data and to explore. And so we'll look a little more in detail at those topics, but JMP really started as this tool for scientists and engineers. And what's amazing about it is, at least with regard to teaching, because of all the visualizations, it makes data exploration very fun. And at least from my point of view, I'm always excited to see my students excited about playing with data. And the word play there I use very deliberately. When we can play with data, we explore and we enjoy it. And I think that's a nice, really, approach to teaching, I think. All right, so that's the basics of what JMP is. Now let's talk about how JMP works. And to do this section, what I'm going to do is open some sample data. It's going to be a little bit simple data. These are restaurant tip data. And the way I'm getting to these data sets, I mean, I'm clicking them in my journal, but just so you can follow along later, the way to get to sample data in JMP is to go to the Help menu. And there's a section here called Sample Data. And when you go to the sample data section, you'll get actually a list of data sets that are organized by types of analyses they're good for. So you can expand a section by clicking one of these gray triangles. And these are all data sets that work for the analysis of variance. So this is a nice way to explore the listing of sample data. But if you have a particular data set you want, you can click Open the Sample Data Directory, and that'll take you to the listing where you can open up the data set I'm working with. Now, we'll come back to the sample data index a little bit later because as a teacher, you'll be interested to look in the teaching resources section where we have examples for teaching, we have scripts for teaching, including many interactive teaching modules and demonstration. And so these are more than just flat or static demonstrations. These are interactive modules that actually let you perform very important things for conceptual understanding and statistics. So for instance, generating a sampling distribution of the mean in real time for students. So these simulations are all just built into the software under that interactive teaching module section. So we'll come back to that, but that's how you get to sample data. So under the Help menu, sample data. And so the one we're working with right now is called Restaurant Tips. And let's just take a second to orient ourselves to what type of data we have. So we have a data set, and I'll scroll down to the bottom so you can see how many rows we have at the end. 157 rows, which is also listed right here, the number of rows in the table. And each one of these rows is a table at a restaurant. So let's imagine that we're the proprietor of this restaurant. We own this restaurant. So we have data for the 157 bills of this past week. And what we have are information on the total bill amount, how much was tipped, whether a credit card was used on the bill, the number of guests who were sitting at the table, which day of last week this was, which server, and in this restaurant we have A, B, and C, so 3 different servers in our restaurant, and we have a measurement of the tip percentage, which is of course the tip amount divided by the bill amount. So these data give us a number of questions we could ask of our restaurant. Maybe we want to know whether tips differ by people who use credit cards or not, or how bill amount goes up with the number of guests we have, or whether certain days of the week are heavier or slower. So these data allow us to ask a number of different questions, but how are we going to tell JMP what questions we want to ask? How could we communicate to JMP that we want to look at the distributions or comparisons among these different variables? So that's where we get into the topic of the mind of JMP. And again, being an experimental psychologist, someone who thinks about minds, that's how I like to think about software, as if it had a mind. Now, of course, software doesn't have a mind. It is simply the sort of combination of all the programmers and developers and the way they think about data. But together, all of their input or all their development created a piece of software that I think has a little bit of a mind of its own. And I like to tell you a little bit about that mind. So when you work with JMP, you know exactly how to communicate with it to get the most from it. And to start this topic, I want to give you just a little pithy phrase that JMP is more concerned with the situation than the statistic. So JMP organizes its mind around the situation and not the statistic. So what do I mean by that? Well, if you've used other statistical software, or even if you haven't, you may have some familiarity with how you produce analyses in other software. In many software, you go to a particular analysis from a menu. So you'll go to the Analyze menu in other software, and there'll actually be a section for t-test under the Analyze menu. So software like that is really organized around the statistic. What are you trying to calculate? And you pick that statistic from a menu, and usually the software will give you then the option to specify, where the data is coming from. Now that's not JMP. JMP is actually built around situations, not individual analyses. And by that I mean these platforms, that's what we call these different sections of JMP, these rooms in JMP, are situations of data analysis. And so let me tell you about a couple of them. So distribution, the situation that applies to is anytime you're interested in univariate or one variable questions. So that could be a histogram, it could be getting quantile plots, tests on means, right? Those are all one variable questions. So that platform is about the situation where you're interested in one variable at a time. Now we'll contrast that with a platform we're going to look at in a minute, fit y by x, which is a different situation. That is the situation where you have one y variable, something external you want to predict, on the basis of some x variable, so one y and one x. So these are different situations. They're not tests that we're picking out from a menu, but situations we want to launch into. So that's the basic idea of JMP. JMP is built around situations. So how does it carry this off? How is it that JMP is going to allow us to sort of define what we want to do, and how will it know what type of analysis we want? Well, there's 2 additional components that are important about JMP, and that is that JMP pays attention to something we call the modeling type in your data. And I'll unpack that in just a minute. So if you've never heard the term modeling type, don't worry. So JMP pays attention to that, and JMP is structured to be progressive. That is, it unfolds. And so I'll unpack that too as well. Now, to sort of describe these two, what I'm going to do is produce a simple analysis, and I think you'll see what I mean in that JMP pays attention to modeling type and is progressive. So what I'm going to do, let's go back to our data set. Now remember that platform we just used, the distribution platform. Remember I said that's the situation where we care about one variable at a time. So let me open that platform, and I'm going to select 2 columns here. I'm going to select tip amount, and I'm going to click Y columns. That'll enter it into the Y roll. And just so you see there's another way we can do this, I'm going to drag credit card across. And so let's pause for a second and think about what we're asking JMP to do in this situation. So we've chosen the room we want to go into. We've chosen the situation. It's the one variable situation, distribution. And we're telling JMP right now we want to look at the distribution of tip amount and credit cards. But let's pause. Look at the type of data in the tip amount column. Those are dollars. Dollars are on a real scale. Formally, that's a ratio scale. Right? These numbers actually have a meaning. $5.01 is an actual amount greater than $3.61. Now, look at the other column we selected, credit card. The values in that column are Y's and N's. Right? Those are categorical data. They don't have a true scale. They're not the same type of data as dollars. right? Formally, we would call those measurements on a nominal scale. Now, jump, you might notice, is even giving a different icon to these two different columns. Jump knows that credit cards are categories, whereas tip amount represents actual continuous scale measurements, right? These icons actually reflect the fact that Jump knows something about these columns. Let me click OK, and I want you to see what Jump's going to do when it produces the output. On the left-hand side is our output for tip amount, so that's our quantitative variable. And notice that Jump has produced or has calculated statistics for us, like a mean and a standard deviation. It's given us quantiles. And the visual representation of the data, this histogram, is actually a true histogram. It's binning the observations into different sections. Now look on the right. This is a different type of data. These are different data, of course. They're categorical. Jump has produced a frequency distribution plot. It's showing us here the frequencies of yeses and the frequencies of nos, and it's giving us a frequency table. So Jump knows what to show you for these different columns. I did not have to tell Jump I wanted frequencies. It knew that was the appropriate thing to produce. And so that's how modeling type affects the data. Modeling type, either categorical data, nominal or ordinal, produces particular types of analyses in Jump. Rather, Jump knows what to do with those data. And when Jump is treating data as continuous, it knows to produce output like this, with a histogram or quantiles. Now, just so you can see how easy it is to change these things, since Jump will never force you into a particular way of thinking about data, if you're in the data set, look at the columns list here. And so these columns, if I select one here, notice they select everywhere. The icons next to each column or each variable are clickable. So if I click the icon next to tip amount, notice it'll give me a drop down to select what type of modeling or what type of data these observations are. Now, I'll give you a little bit of a sort of a general scope here. If Jump sees data in a column and it's only numbers, Jump will assume those measurements are continuous, that they reflect real measurements of something scale. But if Jump sees anything character in a column, like it sees Ys and Ns, so it sees actual text, Jump will assume that the measurements are nominal, that they reflect categories in the world. Now, just so you can see that this will have consequential effects, so I'm going to click on this icon and I'm going to change the modeling type for tip amount to be nominal. So what I'm telling Jump is that every unique value in this column reflects a different category. And now this is not something I suggest you do, but I want you to see the effect it has, because this gives, I think, a good idea about why Jump is doing this. So let me go back to Analyze. I'm going to go to Distribution. This is what I just did before. And just so you see I'm not cheating and changing anything else, I'm going to click the Recall button. So what this will do is bring back everything I entered the last time I used this platform. And notice Jump obliges, and it brings back in those two columns I used. Now, let me click OK, and I want you to compare the outputs that I got. Because on the left-hand side, this is the output I got by treating tip amount as nominal. It's produced a frequency distribution plot. That's what we told Jump to do, of course, because we told Jump that those measurements didn't mean numbers, that those were actually unique observations. So Jump will honor whatever you tell it to do, but it'll make very good guesses for you. So let me go back here, and I'm going to set tip amount to be back to continuous. So I'm going to click on the icon and just turn it back to continuous. All right, so why do this? Why have Jump contextualize the output? Well, I think you can see that it saves some time. If I don't have to tell Jump that I want frequencies or summary statistics and it just produces it on its own, then we can work in flow. We don't have to specify things multiple times that Jump already knows what to do with. That's only one reason why Jump does this. There's actually a more substantial and beneficial reason to pay attention to modeling. And that's the progressive interface, the way Jump lets you produce analyses, but then lets you dig deeper. And so what I mean by this is that as you produce analysis in Jump, new options will appear. And so you're never stuck in an output. You're never at a dead end. And the way you keep moving, the way you move forward, is by using these little menus, the red triangle menus. So if you're a new user to Jump, this is really important to take note of. These red triangles are all menus. And so whenever you see a red triangle on the screen and you've never clicked it before, click it. Look in every red triangle menu, because these menus are the ones that let you do more things. But they let you do more things in a very specific way, in a way that makes sense given what you're actually working in or what context you're in. So let's actually click one of these and let's see what I mean by that. So the red triangle here next to tip amount, this is a red triangle that'll give me options to do more analysis on a quantitative column in the distribution room, so the room that's all about one variable questions. And so let me click on that red triangle and take a look at these options. So things like getting a normal quantile plot, or producing a stem and leaf plot, or testing the mean, right? If we're in a one variable room, then this is us testing a one sample mean. So these options are all the things we can do to keep moving forward with our analysis. So for instance, if I'm looking at these data and maybe I have some reason to think that we should have a normally distributed distribution of tip amount, maybe I want that quantile plot. So if I go to the red triangle and select normal quantile plot, JMP will produce the output in line. And so this is a special thing about JMP. I didn't have to go backwards or reset up this analysis. Once we're in the platform, we can continue to go further. And so that's an amazing thing about JMP, that you can basically be in an analysis and keep asking questions without having to go backwards. All right, let me turn off the normal quantile plot just to save some screen real estate. Now, let's look at this menu. So this is the context or the red triangle menu for a quantitative column. Compare that to what I'm going to get when I click credit card. Now, get some intuition about this. If we think about what types of operations or analyses are applicable, it's not going to be this list over here, right? We couldn't possibly get a normal quantile plot for a categorical column. We couldn't test a mean. There is no mean for a categorical column. So we should not expect JMP to show us these options. But can you think of which options JMP should show us? Let's take a look at them. So things like a different representation of the data, a mosaic plot, so another way of representing share, right? That makes sense to do. What about testing proportions or probabilities? So you may have thought of this, a one sample chi-square test. Maybe we think there should be some particular frequency distribution in the population or proportionality, and we can test that. Or maybe we want confidence intervals about the frequencies, right? So JMP knows to give us different options because these columns reflect different things in the world. And so this is an amazing thing about JMP, because as you produce analysis, JMP produces output that makes sense, and it will continue to give you options that make sense. And this leads to, I think, very substantial workflow benefits, so for efficiency's sake, but also pedagogically. JMP knows to offer you things that make sense, so I even learn new tools and techniques because I happen to be in a place in JMP where it offers me an analysis I may never have seen before. All right, so there is one thing I want to point to, which is the statistics index. So if you're looking for something really special in JMP or particular in JMP, sometimes it could be under a couple menu levels. So if you were looking for, let's say, fitting a normal distribution to this, notice it's under a couple levels. So you might have a hard time finding some of these options when you're first getting started. And so the way to find these a little more easily is to use the statistics index in JMP. So I want to point that out to you. It's under the help menu, and it's given as the statistics index. So you can search for whichever particular analyses you want, and it'll let you know where it is in JMP. All right, so that's the basic mind of JMP. That's how we actually tell it what we want it to do and the way it produces analyses for us. Now let's talk rather briefly about how we get data into JMP. And I say briefly because this is a very quick topic. It is as easy as Excel or Word or PowerPoint. It's simply going to be file open. Now, I already pointed out the sample data. That was a special way to get to data under the help menu. But just so you can see what it looks like to actually import some data, let's try importing some text data, since you can import from text, from Excel, SPSS, whatever you really want. So I'm going to go to File Open. And again, it's as easy as doing File Open. And what I want to do, let me actually get to my sample data. This will be a little easier. So I'll do Open Sample Data Directory. And what I'm going to do is, if you ever want to try importing data, the sample data directory actually includes some data from different programs. So you can actually see what it looks like to import from comma delimited files or from Excel files, whatever you like. But I'm going to try just a very simple one. So a bigclass.txt. And so this is a data set that's just going to be in pure text. Now, when you open up a pure text file, you can actually open them up in JMP as text. But normally what we want to do is import things as data. And in JMP, let me actually back up here. There's an easier file to do this with. When you import files as data, JMP will actually make guesses about the type of data each column is. And this is what I mentioned before. When you actually have data that comes in as all numbers, JMP will treat it as numbers. And when you enter data as text, JMP will treat it as text. And so let's try one of these that's on a sandwich. This is not bad. This is an Excel file, just so you can see JMP is happy to pull in data of any type. We can do one more. Let me do an SPSS file. I think I have one in there so you can see. So really, no matter what programs you come from, JMP will really just bring in the data without really much complaint. I don't know if I have an SPSS file here. Point is, opening data is not a command line. You don't need to do anything special. Simply file open and point your JMP to the data you want to open. There is one very special way to open data we're not going to talk about today, but that's the internet open option. So if you have data on a website or data on a Wikipedia table, so if you have tables on a website in HTML, JMP can actually parse a web table. So if you find data online, you can simply tell JMP what the URL is, and JMP can even open that as data. And so a lot of ways to get data into JMP. Now, certainly, you can copy data from another source, or maybe you're entering in data on your own. So you don't have data already, but you need to make a new table. And so to make a new table, again, think like regular modern software. Under the File menu, you can simply go to New and create a new data table. And this will open a blank canvas, so a blank data set. And you'll notice, and this surprised me when I first started using JMP, we have no row numbers yet. That's because we have no data entered in. As soon as you start entering data, JMP will start populating the rows. So let's suppose that column 1 represented, and I'm taking measurements, let's say on age. And so we measure somebody with 25 years old. Notice JMP adds the 1 here for me. Now, if you want to add additional columns, you can do that from the columns menu. You could add many at once or add just a single column. Another simple way, just double click in a blank space and JMP will add in the columns for you. If you want to add in more than one at a time, click in a blank space past a blank space and it'll add in columns up to that number. And so very easy to make data sets and of course, very easy to save them. File save saves them as a JMP file and file export on the Mac lets you save them in different file formats. So like a DAT file, CSV file, whatever you like. On the PC, you can simply do Save As, and there's the option for different file formats. All right, so that's basics of getting data in. Fairly straightforward. Now, what I want to do at this point is pause briefly to see if Gail has received any questions that we can talk about at this point. Otherwise, I want to talk about some essential platforms, and then we'll kind of revisit the idea of resources and talk a little bit more about those.
Hi, Julian. I'm not seeing anything in the chat or Q&A. A reminder to everyone, if you do have questions, send them via the chat or the Q&A to me, your host, Gail Massari. I'll give it about 10 seconds to see if any come in. Nope, not so far. But if you have any questions about what Julian has already covered, we can get back to those at the next break if you send me a chat or a Q&A to Gail Massari.
Perfect. Well, thank you, Gail. Fantastic. Well, let's talk about some essential platforms now. And I'm going to keep this data set open for a minute. We can still work with this one. But let's talk rather generally about these platforms, and then let's dig into each one. So again, remember, in JMP, platforms represent situations or rooms that you want to do different types of analyses in. In each of these situations, each of these rooms have different tools. Just like if you were to go into the kitchen in your house, that has particular tools that are good for cooking, right? Those are different tools than you'll find in, let's say, your bedroom, right? So rooms in JMP sort of operate like this. They each come with their own tools, and they are all each differently equipped for different situations. So the distribution platform, as we saw before, was equipped for one variable questions. Not that you have to do one variable at a time, just that the analysis options all relate to individual variables. Not about relationships, but about each one at a time. Graph Builder, which we'll talk about in a second, is really a graphing platform and one that's interactive and very versatile. And so that's when your principal interest is really in showing relationships or showing results, or even just exploring and getting to know your data set. Now, FitY by X, which I talked about briefly, that's the situation where you look at two variable relationships, so one Y and one X. Now, this is fairly general. That could be a t-test, so that is one continuous Y, numeric Y, and a categorical X. It could be linear regression with two variables. So that's one continuous Y and one continuous X. And finally, Tabulate. Tabulate is the situation or the room where you're most interested in making tables. And so this is a drag and drop table and aggregation platform. Now, those are the ones we'll talk about most. I do want to point out two a little more advanced platforms that you'll need if you're teaching or taking a class that's more of a second course in statistics. And that's FitModel, which is a general modeling platform. So that could be one Y or multiple Ys with one X or multiple X's. And that's a broad range of different models. So that could be multiple regression. It could be, partial least squares. There's many options in there. But we'll touch briefly in fit model, and I'll show you what that looks like. And then finally, multivariate, which is a platform that's all about looking at interrelationships among a lot of variables all at once. So that's the general overview of those platforms. Of course, that's not everything in JMP. If you look under your Analyze menu, you'll see lots and lots of options, and there are some very specific ones that are really a particular or important analyses, so things like neural or nonlinear. But today, we're only going to talk about really the most used and biggest platforms. So let's actually start with distribution again. We've looked at it a decent amount, but I want to just point out some special features of distribution. And so let's produce some output. I'll go again, Analyze, Distribution. And let's take a couple more columns this time. So I'll take bill amount all the way down to server, and I'll click them into Y. So notice I can take as many columns as I want, and this is actually a great way when you're first getting to know a data set. Take all your columns, put them into Y, and click OK. And the benefit of this is you get to look very quickly at the distributions of all your variables. And you will notice very quickly if there are inconsistencies or there are problems. Now, I pointed this out before, but in JMP, everything is linked. So if I click on the credit card yeses, for instance, click on that bar, what you see shaded are those rows everywhere else in all the other distributions. Now, there's something special about this. When I clicked the Y columns, when I selected those rows, they're also selected in the data set. So notice that every row that counted as a yes is actually selected here as well. Now, why do I say that's important? Well, let's look at the tip amount column. Notice that there's an observation here that has a really high tip amount, so $15 if I hover over it. What if I wanted to find that point? What if I wanted to find that person in the data set? Well, I could just drag a box around it. Now that it's selected in here, remember that everything in JMP is globally selected, so I scroll down, well, there's that person who tipped $15. So notice that being able to touch your data and connect it, this is actually a very valuable tool for just understanding who your individual subjects are. Now, distribution is very useful for lots of things. We looked under the red triangle menus and saw lots of options there. I want to point out some additional things that are important about this platform. And the first is that the histograms we're looking at here are rotated from what you might usually see. And if you really dislike that option, I want to show you how to change it. And this is a good lesson in JMP overall. If there is something you want to change, almost certainly you can change it. And you could even set a preference for it. And so let me show you how to rotate these histograms to be on their side like you might be used to. And the way to do that is this topmost red triangle, the one next to the word distributions, because that controls the entire output. And under that red triangle is the option called stacking. Now what stack does is it reorients the output to be in the more horizontal way. And if I do that, you may get a more familiar looking histogram to you. Now, I prefer the histograms actually on their side. You can see a lot more of them, which is very valuable since you can select in a distribution. But if this is more familiar, then certainly remember that option under the red triangle and go to stack. And I mentioned that you can set preferences for any of the options you see in JMP. And so I encourage you, if you're constantly stacking your data, if you're constantly going in and rotating the output, go to your preferences. On the Mac, it's under the JMP menu. On the PC, it's under File. And in your preferences, there'll be a section for platforms. And in here, you can set preferences for whatever platforms you find yourself using all the time. Personally, what I would do then is go to Distribution and click the checkbox for Stack. That way, every time I produce distribution output, JMP will produce it in the stacked format. So these are little interfaces in JMP. So make them the way you want them, and they'll always look that way. All right, so that's the distribution platform. It's really all about one variable at a time. But it has the valuable characteristic that you can click on observations and you can actually see in every other distribution where those observations are. It's also a great way to look for outliers and to screen your data for data problems. So maybe somebody entered in days of week incorrectly. You would catch that there rather quickly. All right, so that's the distribution platform. So everything is context dependent. You get different output depending on the modeling type. And dynamic linking, you can click on a histogram bar and you'll see those observations everywhere else. All right, so let's show Graph Builder, because Graph Builder is a pretty impressive platform. And we'll use this data set for a second, but then I'm going to show you in some other data some of its special features. Now you'll find Graph Builder under the Graph menu. And there's plenty of different graphing options in JMP, but Graph Builder is a pretty special one, because Graph Builder is really a catch-all. It's a multi-use platform that produces many different types of graphics, but it's all drag and drop. You don't have to use any kind of dialogue for this platform. Instead, you simply put the columns in the places they need to be to create the visualization you think you want to create. And I say think because sometimes we don't know if a visualization will actually work or tell the story in our data until we see it. And what's powerful about this modality of creating graphics is we can try things out and agilely change on the basis of what we see. So for instance, maybe my principal interest is understanding tip percentage. And so I'm going to treat that as my Y variable. So I'm going to grab it and I'm going to drag to the Y axis. And if I drop it here, notice what jump does is it has tip percentage now on the Y. Now, you may notice that these points are spread out here. They're jittered in X space. We actually don't have any X variable, so the only thing jump can do is spread them out so we can see the cloud. If you uncheck the box for jitter, you'll see that's the observation, or that's the output you get. Probably not a very good way to see the data. So I like to leave jitter on. But at this point, we don't really have a very compelling visual. All we're looking at is really the distribution of tip percentage. Let's actually see if tip percentage changes on the basis of something. What about whether somebody uses a credit card or not? So I'm going to click and drag credit card to the x-axis. And notice what jump does. Now we have an x variable, so the no observations are all on one side and the yeses are on the other. And what's nice about the points is we can actually see not really just where the center is, but also a little bit about the spread. But maybe you want an actual summarization of these. Maybe you want a bar or a box plot. I want to point your attention to the ribbon at the top of the screen. As soon as we put those two variables into Graph Builder, Jump showed the options that make sense. So for instance, a pretty typical visual might be a bar chart. So there's our bar chart for no's and yeses of credit cards and for their tip percentages. We could even put error bars if we want. Notice the control panel on the left gives us new options depending on what type of visual we select. So maybe we want an error here with one standard error. Now, maybe we don't want bars. Maybe we'd rather have a box plot. We can click on the box plot icon and Jump will switch the visual to be box plots. We can have new options. We can change the styles. We can change what type of box plot they're showing. So Jump makes it very easy to switch between different visualizations, and this is something I really like about Jump. Now, before we move on to a different piece of data, let's actually look at some of these other drop zones. Notice we have a zone here called Group for X. We have a zone called Group for Y. We have Wrapping, Overlay, Color, and Size. Now, these are all different components of this plot that can actually change. And let me show you how to use some of these. So grouping for X. So this will split up the X-axis into different groups. So for instance, what if we wanted to look at the credit card no versus yes box plot, but we actually wanted separate pairs of box plots for different servers? So we have 3 different servers in our data set. So we're essentially asking for 6 different box plots. Let's see how we would do this. I'm going to take the server variable, and I'm not going to drop it. I'm just going to hover it over Group for X, and I want you to see what it does. So take a second to look at this. What we have is server A, B, and C, and within each of those sections, yeses and nos. And so that's what Group for X does. Now, Group for Y, if I move the variable down here, notice it does really a complementary one. So splitting up the Y-axis rather than the X on the basis of those levels. Now wrapping will actually go from left to right, which works well when you have an even number of these, or if you like, you can change the number of wrap points. But notice what this does is moves from left to right and then down. So another way of splitting up or trellising the plot. And finally, the one we'll use here is overlay. Overlay in the same plot adds in another nested level. So in this case, servers A, B, and C for no are all right next to each other, and servers A, B, and C for yes credit card are all right next to each other. Now I'll pause for just a second and address a question I often get when I teach, which is, what is the right graphic for these data? And that's an interesting question because it is one that always prompts another question from me, which is, what are you trying to show? Because data don't give you the story. The story is what you make of the data on the basis of your content knowledge of an area. So what to show depends on what you think there is to show. So for instance, if my main interest in this example was to show that the difference between credit card use yes and no for the different servers is very similar. What I may want to do is have the observations or the output for the different servers next to each other. So that would be something like this. Server A, B, and C as separate sections, and now I can compare really easily the no's and yeses. Notice perceptually, the no and yes for each server is closer together, so it's easy to compare. Whereas if I drag this column over to overlay, notice what happens perceptually. If I want to compare server A's yes answer to no answer, that I have to move from here all the way to over here. So my point being, think perceptually about what's most going to convey your message and create the visual that makes sense. And I think Graph Builder is a nice way to do this since you can explore different visualizations. Now I'm going to close this data set because actually I want to show you with a slightly different data set some additional things you can do with Graph Builder. Now, what I'm going to show you here are some data for SAT scores for the different states in our country. And we have a number of other variables that give us nice contextual information about expenditure or population. But principally, we're interested in these SAT scores, SATs, verbal, and math. And what we have are observations over different years. So for each state, we actually have 8 observations. Now, what I want to show you is in Graph Builder, how we can do some pretty fun things with geographic data. And there was a section we haven't used yet, which is called Map Shape. And this is a wonderful way to explore geographic data. Take a variable like state. Notice in my data set, I have a variable that just says what state are we in, Arizona, Alabama, Alaska, whatever. We take that variable, I'm going to drag it down here to Map Shape, and instantly we get the canvas of our country. And our rows are actually already colored by expenditure, and so Graph Builder has picked up that coloring for us. So these are the states that spend the most, I guess. But we can try different things. So let me grab SAT verbal. I'm going to drag that into just the center. And notice what that does is applies the coloring role for SAT verbal. And now we can look just very briefly to see if there are maybe clusters or different geographic sort of correlates to SAT verbal scores. And so being able to use the map shape section actually enables a lot of very interesting and fun graphical exploration. Now you can still use the other roles. I told you I had different years of data. What if I drag year to a wrap? And look what I get there. So I get a trellis plot of my maps. So I can actually see, not very well, I actually don't recommend geographic maps all the time, but if you wanted to look at maybe whether there are geographic changes from 92 to 2004, this might be a nice way to see that. Right, so Graph Builder gives you a lot of options, and so that's certainly worth playing with quite a bit. And so if we have some time, I may come back to another visual with that. But certainly I want you to see Fit Y by X. Now, this is a very special platform and one that you'll find a lot of use in. And this little icon here is actually from the platform itself. And to talk about this one, I'm going to bring back my restaurant tips data set. And what I want to do is launch into Fit Y by X, and we'll explore a couple different things it can do. So again, under Analyze, Fit Y by X. And like I said before, this is a platform that's all about 2 variable questions. So when you have one Y variable and one X variable. And what we're looking at here is actually a legend. So the legend tells us what type of output JMP will produce based on the modeling types of the variables we use. So I'll say that again. What JMP will produce here is a different output depending on what the modeling type of the X variable is and the modeling type of the Y variable. And that should make sense. Just like in distribution, different analyses make sense when you have a continuous Y or a categorical Y, or when you have a continuous predictor or a categorical predictor. And so I actually love this diagram. I use this in my class almost verbatim because I think it does a nice job of contextualizing or putting into sort of a taxonomy the different types of analyses we have. But remember, JMP is about situations and not statistics. And so the bivariate situation, that is a continuous variable predicting a continuous variable, that includes a number of different analyses. Maybe it's a logistic regression, maybe linear regression, or maybe polynomial regression. Right? Those are both a continuous Y predicted by a continuous X. So let's try one of these. We were looking at tip percentage before when we were graphing. Let's try to actually test or analyze whether tip percentage is modulated by something else. So why don't we try credit card? That was the first thing we tried before. So I'm going to put that in as my X. And when I click OK, JMP's going to produce some pretty basic output. Now, I'm not going to click anything yet because what I want to do is right away go back to Fit Y by X. And I'm going to click Recall. Remember, Recall brings back what we did just a second ago. But what I want to do is I'm going to double click on credit card to remove it. And I'm going to take a different variable, something continuous, like bill amount, and I'm also going to use that as my x. So these are both predicting tip percentage, the two analyses we're about to do. But on the right-hand side, we have a continuous variable predicting a continuous variable. And on the left-hand side, we have a categorical variable predicting a continuous variable. Now let's just pause for a second and look at these two outputs. They're both using dots, right? So we're looking at a scatter plot on the right and really a dot plot on the left. We're looking at the same data, based on different x's, but we don't really have any analysis. All we have are graphics. And you would think going to an analysis platform, we would have analyses on our output window. Now, this is a very important thing about JMP. JMP prefers visuals first before showing you statistics. It's actually a major sort of a basic ethos of JMP. If you can show a visual, because visual representations of data aren't just toys. They give meaning where meaning could not before be extracted. So a visual will often come first before an analysis. And remember what I said at the very start. If you're learning JMP and you don't know what's under a red triangle, click the red triangle, because that's how you go further. That's how you dig deeper. So on the left-hand side, let's remember, red triangles are context dependent. They only show you options that make sense. So let's think about the context we're in. We're in a room that's about bivariate questions, 1y and 1x, and we're using categories to predict something continuous. So really, this is the domain of a t-test. This is the domain of the ANOVA. This is where we're comparing means. So this red triangle, let's take a second to look at these options. Well, we have some basic ones. We can get quantiles, we can get means and standard deviations, but we can also get a means, ANOVA, and a pool T, right? We can also produce a t-test. Notice something else here. There's a non-parametric section. So not comparing just means, but medians, different ways of comparing, right? Even an equivalence test. This is actually the opposite of a null hypothesis test. This is when we want to know whether two things are the same, not whether they're different. Right, so JMP has put all the options that make sense given this context right next to each other. And that is powerful. And I'll tell you why that's powerful. If I'm teaching the pooled t-test, so if I produce the means, ANOVA, and pooled t, so it produces all that analysis output, that's also around the time in my class where I like to teach the Wilcoxon. And in JMP, because it's about situations, those two analyses live very close together. And I prefer that when I teach because those are actually closer together than most software makes them seem. A non-parametric test can address the same question, the same situation, albeit through completely different mathematical ways, but it addresses the same question. And so the fact that JMP is built around questions means that, at least for me, my intuition is that I get more of a sense of what connects to each other. And it gives me the sense of where the spaces are in statistics, not just what statistics have been developed. All right, so this is the domain of that ANOVA, of the t-test, and we produce output just by selecting it. Now I'll make a point, as I produce output, remember you always get options to dig deeper, and you always get visuals if possible. And so under the t-test section, you'll see we have this normal distribution with a shaded region. So you might have some intuitions about what this is, but let me break it down formally. So this is a representation of the sampling distribution of the t-statistic. And what we're looking at is, well, under the null hypothesis, we expect a t of 0 as our expectation, accepting some range. And what we have shaded here is the proportion more extreme than the observed value of t we got. That value of t right there, 0.9526. So what we have shaded here is the two-tailed p-value. It's listed right here, probability greater than the absolute value of t, 0.3423. And I love this visual because as you're teaching or as you're thinking about p-values, it brings you back to what it's actually measuring and what it's showing. Under the null hypothesis, how unlikely would a result be or more extreme, given the null being true. So I love that JMP produces graphics like this in line. So this on the left-hand side, remember, is one particular context. Now let's compare that to the right-hand side. And I'll remind you, this is now the context where we have 1y and 1x, but they're both quantitative variables. So this is more the domain of regression. And let's look at this red triangle options. So we can do some basic things like getting histogram borders, right? So we can modify our visual, but really the most important things are things like fitting a line. So if we want to fit a line between these variables, we can produce that right away. And notice we get very similar output. So one thing that I know our developers work hard to do is make consistent output. And so you'll see we get very similar summary of fits and analysis of variance tables. Now remember, if you're learning JMP and you have not clicked a red triangle, click a red triangle. And this one's very useful. So oftentimes I'll have students turn on confidence curves for a fit, so they actually get the working hoteling confidence band. And really my favorite, or the thing I always make my students do, plotting the residuals. So any of you who teach linear regression know it's very important to look at these, and JMP makes it very simple. So if you click this on, you actually get a bundle of graphics that pour through the different residual plots. And so this is beyond the scope of today, but notice that you can get those residuals very easy and visualize them. So remember, click every red triangle once you've produced an analysis so you know how it is you can dig deeper. Now, my main point, though, is to note that this platform, we're in the same platform on the left and the right, but different contexts. And that's determined by the modeling type of the variables. So on the right, because it knew we had two quantitative variables, it's giving us the options that make sense. And on the left-hand side, because it knew that we were using a quantitative variable predicted by a categorical, it gave us the options that made sense. And so FitY by X is a wonderful platform for that, just because you don't have to specify the type of analysis at the start, rather just the situation and what variables you want to bring along with you into that environment. All right, so that's FitY by X. And there's, of course, two different sections we didn't talk about yet, contingency plots and logistic plots. And so contingency, just so you note, is really the domain of a chi-squared test of independence, or contingency type analyses. And then logistic regression is, of course, when you're predicting categorical variables. So if we wanted to predict credit card use, let's say yeses and nos, on the basis of, say, the number of guests. So we can do a logistic regression in order to make that prediction. All right, but I want to show you Tabulate before we finish up, because this is a very powerful platform and one that I think is underutilized given its value. And so it's under the Analyze menu. And I would say that Tabulate is really the corresponding platform to Graph Builder, but for the creation of tables. And what I mean by that is sometimes we just need a statistical summary or an aggregation of our data. For instance, if this were our restaurant, maybe we want to know how many dollars each of our servers brought in, or how many dollars in tips they brought in, right? We just want a table of figures. We don't want a graph. We just want a table. Now, the way Tabulate works is, and I always encourage people to do this, imagine the table you want, and all you do is take the columns and put them into the places that would generate that table. Now, that's easier said than done. So let's explore a couple of these. So I'm going to imagine in a table, I want to have different rows for my servers. So 3 rows, A, B, and C. And all I want is what their total bill amount is over the entire week, a sum of the values of their bills. All right, let's start dragging columns. I'll take server, and I'm going to drag that to the drop zone for rows. Notice that it highlights as soon as I hover. All right, well, that's looking like what I wanted it to look like. I have 3 rows, A, B, and C, and JMP has given me a statistic. It says the number of observations in those different categories. So, okay, I have equally-ish between A and B, pretty close, but about half as many observations for C. So this should alert us if we're using the sum, we might be concerned about underestimating what C really is doing for our restaurant. Maybe C wasn't working as much this week. But so far, we just have the N. What we also need is some measure of bill amount. And so I want to show you how to get that into the table. If I drag it, notice you're going to want bill amount right here. That's where you want it to be summed. So if I drop it there, that tells JMP, use that as a statistic. Use that to show me something about the different servers. And what it does is it chooses a default summary statistic. It turns out that the default summary statistic is the sum. But if we wanted to change it, we have plenty of different options. Plenty of options. So we can drag, for instance, the mean. And I could drag that on top of sum as a way to look at the average now, dollar amount. Or maybe we want 2 different things. We want a mean and a standard deviation. I want to show you how to do that. We can take standard deviation. Now, if I dropped it on top of mean, remember I just did that before. That's in JMP's mind, the replace action. If we want to add it to this table, notice what happens if I go to the right-hand side. There's a tiny little drop zone there, or even on the left-hand side, there's a little drop zone there. And if I drop standard deviation there, in JMP's mind, that means add it to the table. So look at this. I can create very quickly these complicated tables with different summary statistics, and I can even drill down further. So maybe I don't care just about server, but I want to compare with credit card use, yes and no. So I want within server A some difference in mean and standard deviation between when server A used credit cards versus not. So I want to show you how to do that. This is fun. So let's take credit card use. And remember the little rule I just told you. If you drop on top of server, that will replace it. So let me click undo. Undo is a really good thing to have here. Instead of dropping on top of server, I want to use those little drop zones to the right or left. And depending on how you do this is pre-pending and this is appending, and they'll have different consequences. So let me drop it to the right-hand side. And so that nests credit cards inside of servers, so we can compare yeses and nos pretty directly. But like I said before, for graphics, the table you make depends on the question you want to show or the answer you want to show. So I can imagine a situation where I would rather have, I'll drag credit card to the left now of server, something like this, where maybe I want to compare within credit card no, the different servers, and within credit card yes, the different servers. This might give me more interesting information or somehow highlight an effect I'm interested in. So certainly explore with these tables how you want to create them and try out different ways of really showing the observations. Now, when you click done, that'll close the control panel. And if you want to save the table, you can go to red triangle and save. Yes, Gail, I can hear you.
Just so you know, we only have 2 minutes. And
yes,
you do have some
I just saw that there.
So we should probably.
Mm-hmm. And so I'll just say the last little bit one real time, which is if you want to make this tabulation into a proper data table, remember always click your red triangles and you can select make into data table. And this will generate a data table out of that aggregation. All right, so that was Tabulate. And if just a second I have left, I'll just talk briefly again. Fit Model is the general modeling platform, again, under the Analyze menu. We won't have time to talk about Fit Model, and that's certainly the topic of some of our other webcasts, but this is a very general platform. So this is where you would do factorial ANOVA. This is where you would do multiple regression. It's the more powerful big brother to Fit Y by X. And then finally, Multivariate is a great platform under the Analyze menu. Multivariate methods, multivariate, which will allow you to investigate relationships among a number of variables all at once. All right, so in the last little bit, I just want to remind you of some of the resources we have. Jump.com/learn is a really great place to start. If you're looking for individual pages or videos on particular analyses, that's a really good place to go. I think our webinars are nice to give you the sense of how to move through JMP, how to work in flow, and how to think about JMP and the statistics the way we do them. But the Learning Library videos are great when you need to learn a particular procedure. And so if you need to pick up how to do correlation in JMP, go to the Learning Library, jump.com/learn. Now, if you're teaching statistics and you want to explore the concept discovery modules, again, these are all under the Help menu in JMP 12. So under Help, Sample Data, there's the section for teaching scripts. And so I encourage you to play with these interactive teaching modules. If you're using JMP 11, you can get these online at jump.com/tools. And then finally, I want to remind you that we have plenty of webinars and webcasts. And so we have Getting Started webinars every Friday. The Mastering JMP web series is a phenomenal web series that Gail leads for more advanced procedures. And we have all of our academic recordings and webinars available on the website. And so visit us at the JMP Academic Community at jump.com/academic, and you can get to all of our resources there. And I really thank you all for joining us today. I know we went pretty long, so I will be happy to stay if there are some questions. But my email address is here, and I'm always happy to talk about teaching and how best to learn JMP. So please feel free to reach out and let me know how I can help you get the most out of your JMP software.
Thanks, Julian. And we do try to close promptly at 1 o'clock out of respect for people. So do write down Julian's email if you have a question. But this is one. I will send people links to how to export reports. It's a whole hour session. One of Julian's colleagues did that. There were 3 videos. I will send you that link. And Julian, I'm going to send them the link to where this recording will live. Do you have any idea how long it'll take for it to get out there? Oh, yeah, I'll have it up there in the next couple hours. So probably around, West Coast time, 2 o'clock today, probably. Great. Now, there's one question. Go back to any kind of graph, because this is something that applies to all of our graphs. As I chatted to the person, if you have a graph, JMP is context sensitive. Why don't you do one that has the points? Sorry, Julian, maybe a graph builder or something. That it's context sensitive. Right click is your friend in JMP, so if you have something and you right click on it, you'll see all the options available. This particular person had a question. They're, say, interested in that point, Julian. How could they label that point?
Great question.
First of all, select that point and label that point. And this applies to lots of the graphs that Julian has showed.
That's a fantastic question. So drag a selection around it. You'll see the other points get grayed. When you right-click it, you can do a couple things. I like to give it a row marker, and that will then give it a marker in the table. So every time that point is graphed, it'll show up as a star. Now, it's also in the table as a star. So if I go to the table and find the point, you'll see it's also given as a star here. Now, one of my favorite tricks, and I'll end with this one. Let's say we have a group of points, and we want to label all of them. We want to actually group them in some way. Grab the points, right-click, and use the name selection in column. Because what this will do is give you the option to give a label. I'll just use the defaults. And what it'll do is in our data set, every one of those that I had selected gets a 1 in that label column. And so again, that trick was you grab the points, right-click, name selection in column. A great way to keep track of little selections you have.
And while you're there, I said we were going to end. I lied. The same would be true of the axes. If you want to make any kind of change to an axis label or to make the font bigger, you can go to the axis. You can go to the
so the
title
axis,
and make your changes there.
And axes you can drag, you can change. So certainly hover and click and drag. Remember that JMP is modern statistical software, so those affordances like clicking, dragging, right-clicking, those are all active. So treat JMP like you would an iPhone. Make sure you try out these little tricks so you get the most out of it.